You type this URL and boom, you get a response. But do you know what really happens behind the scenes inside Kubernetes to make that possible? It looks simple on your browser, but Kubernetes is doing a lot of heavy lifting to make sure your API request reaches the right place and comes back with the right response all in milliseconds. But understanding how that happens in Kubernetes is crucial in debugging real-world issues. Hey there, welcome back to my channel. In this video, I will walk you through the complete behind-the-scenes journey of your API request. From the browser to the load balancer, through the Ingress Controller, service, Kube-Proxy, and finally to the pod that handles the request. Let's jump into it and decode how Kubernetes handles all these complexity. So when you hit the API URL in your browser, the first thing that happens is DNS resolution. Your browser looks up the domain name example.com. It finds the public IP address of the load balancer sitting in front of your Kubernetes cluster. The load balancer is like the front gate of your cluster. It accepts the traffic from the outside world and forwards it inside the Kubernetes cluster. Next, your request reaches the Ingress Controller inside the Kubernetes cluster. Think of Ingress Controller as a traffic manager. It checks the request path like /API/users and decides which service inside the Kubernetes cluster is going to handle the request based on the predefined rules. Once the Ingress Controller knows where to send the request, it forwards it to the Kubernetes Service. Service is like a virtual load balancer inside the cluster. It doesn't process the request itself. Instead, it defines which group of pods should handle the request based on the labels. Behind the scenes, the Kubernetes service maintains a list of healthy pods, and this information is shared with the Kube-Proxy, which is responsible to route the request to one of those pods. Kube-Proxy is the component that ties everything together. It runs on every node in a Kubernetes cluster. Its main job is to watch the Kubernetes API server and keep an updated list of services and their associated pods, also called endpoints. When you send a request to the Kubernetes service, the service itself doesn't process or load balance your request. Instead, the Kube-Proxy uses the information about which pods belong to a service and sets up the routing rules to forward your request to one of those pods. It uses technologies like IP tables to route your request efficiently, even if the target pod is running in a different node. Thanks to Kube-Proxy, your API request is automatically load balanced across all the healthy pods without you ever knowing which pod is going to handle your request. Finally, your request hits the pod, which is basically a running container of your API. The pod receives your request, processes it, talks to various systems wherever required, and finally prepares the response. Once the pod has the response ready, it sends it all the way back through the node, Kube-Proxy, service, Ingress Controller, load balancer, and finally back to your browser. All this happens in milliseconds without you ever knowing how many layers Kubernetes went through to make it happen. And that's how Kubernetes handles your API request behind the scenes. From your browser to the load balancer, Ingress Controller, service, Kube-Proxy, and finally to the pod. All this happens in milliseconds. And now you know exactly what is going on under the hood. How was the content? Did you enjoy it? Make sure you hit the like button and subscribe for more beginner-friendly Kubernetes content. And if you want me to go deeper into topics like Ingress, Kube-Proxy, Kubernetes Networking, just drop a comment and I will make a deep dive video for you. Thank you so much.